Alright, so today we're going to explore more with some rate of change problems, but instead of just looking at the rate of change for linear functions, today we're going to look at how can we find the average rate of change if we have some nonlinear functions. So let's start with some sort of nonlinear function. Let's just start nice and easy with the function like x squared. And we want to try to find the average rate of change from x equals 1 to x equals 4. Okay, so how are we going to do this? So what we know about rate of change when it's linear is that that rate of change is constant over that entire interval. That's what makes the average rate of change the same on that entire line. That's what makes it linear. Okay, so with this function, x squared, this is a quadratic, and so the average rate of change is not constant. If we graph this in Desmos, this would graph some sort of quadratic, which we'll talk about later on in the year. But we can see that we have a curve here, and so this average rate of change is not constant. Okay, so we can still find the average rate of change on this interval, but just like with our formula for slope, we need two ordered pairs, two coordinates to use to find the average rate of change. Well, to start with, we already know two x values, right? We know x equals 1 and x equals 4. So all we need to find the average rate of change on this interval is we need to find out what are their corresponding y values. Okay, so you maybe used a slope formula that looks something like this, y2 minus y1 over x2 minus x1, maybe use that. So we're going to use a slightly different formula, same formula, just a little bit different with how it looks. We're going to write it like this, f of b minus f of a all over b minus a. This is going to be our formula for the average rate of change. Okay, maybe your teacher even shows you this formula. Well, what does it mean? How are we going to use this? So to use this formula, we know the x values. They're still going to go on the bottom, 4 minus 1. But this formula gives us some sort of visual for how to find the corresponding output values. So instead of f of b, we're going to find f of 4 minus, instead of f of a, we're going to find f of 1. And so our formula to find the average rate of change from 4 to 1, or from 1 to 4, is going to be f of 4 minus f of 1 all over 4 minus 1. So then all we have to do to find those values is just to plug them into our function. So f of 4, we plug in 4 into our f function. 4 squared is 16. We find f of 1 by plugging in 1 for x squared. 1 squared is 1 all over 4 minus 1. And so now we have values that we can use to evaluate this average rate of change. 16 minus 1 is 15. 4 minus 1 is 3. 15 divided by 3 is 5. And so the average rate of change from x equals 1 to x equals 4 is 5. Okay, now just briefly, I'd like to kind of talk about what value did we just find? What does this represent? Because when we look at our linear functions, that rate represents the slope of the line. But if we have a curve like x squared, this 5 still has some sort of representation. Okay, so let me go ahead and graph this in Desmos, and then we'll talk about what this 5 represents. Okay, so this is my graph of y equals x squared. So what we want to talk about is we just found an average rate of change of 5. What does that 5 represent if I have a curve like this? So if we draw a line that connects x equals 1 to x equals 4. So first thing we see is we have this ordered pair, is the ordered pair 1, 1, which is what we just used a second ago to find the average rate of change. And we see that this ordered pair is 4, 16, which is the other ordered pair that we use to find the average rate of change. So when you find the average rate of change of a curve, what you're really finding is you're finding the slope of this line that's connecting those 2 points. Okay, now this line has a name to it. It's called a secant line. And so when you find the average rate of change between 2 points on a curve, what that average rate of change represents is it represents the slope of the secant line. Okay, now you maybe noticed that when we found that average rate of change, it was a positive 5. So a positive rate of change is an indicator that the graph is going to be increasing on the interval from 1 to 4. So you'll dive more into that in Algebra 2. But something to keep in mind right now is if you find a positive rate of change, then that's going to show us that our graph is increasing. If we have a negative rate of change, that's going to indicate that our function is decreasing over that interval. Okay? Okay, so let's just look at one more example to find the average rate of change. So we have a new function, f of x equals x squared minus 3. We want to try to find the average rate of change from x equals 2 to x equals 5. Okay, so using our modified formula, we would say f of 5 minus f of 2 all over 5 minus 2. So this would be our formula to find the average rate of change from 2 to 5. Okay, and then to find these values, the corresponding output values, f of 5, we plug in 5 to our function. 5 squared is 25, minus 3 is 22. Plug in 2, 2 squared is 4, 4 minus 3 is 1. And then 5 minus 2 would give us 3 in the denominator. 22 minus 1 is 21, divided by 3 is 7. Okay, so we just found the average rate of change from 2 to 5 is 7. If you think back to our conversation a second ago, what does that 7 represent? If we drew this function, x squared minus 3, and we had some sort of quadratic, it would tell us a couple things. First thing that it would tell us is if we drew the secant line from x equals 2 to x equals 5, we would see that that secant line has a positive slope because we have a positive rate of change of 7. Okay, and then the next thing that we would see is if we look at that average rate of change and we see that is positive, then that shows us that our graph is increasing from x equals 2 to x equals 5. So it gives us a slope of the secant line, but it also tells us that the function is increasing from 2 to 5. All right, so thanks for watching. Good luck with your worksheet today, and let your teacher know if you have any questions with finding the average rate of change of a nonlinear function.